Hello all, I'm Assistant Professor Omkar Kapdi from ISS College Street. Okay, so I think this is our day second of our session, that is Internet of Things. Okay, so in this session we are going to learn some practical applications of Internet of Things. Okay, so I think without wasting more time, let's get start our today's session. Okay. So the first, before going to start our session, I want to share you one PPT. Okay, with you. Okay. So I think you are able to see that PPT. Okay. Okay. So this is our PPT. Okay. And what is today's topic? That is how can we connect devices or components. Okay, in IoT technology. Okay. So in this topic, we all know that what is IoT. In IoT, we are going to connect multiple devices, multiple objects, multiple non-living things. Okay, we are connecting multiple things by using a common network, that is internet. Okay, and we are making a system, and this whole system will provide us a comfort. That is the Internet of Things. That is, we can say that that system is IoT. Okay, that system is based on that IoT technology. Okay, so if you want to learn how we can components, how we can connect the components in IoT technology, the first term you should know, that is embedded system. So what is embedded system? See, the embedded system is a combination of software and hardware system. Okay, so this system is basically based on the computer system. Okay, and the embedded, what is the basic definition of embedded system? It is embedded system is a combination of hardware and software. Okay, so in the topic, the first point is sensors. Okay, so what is sensors? Okay, sensor, we can say that what is sensor, we can say that sensor is a subsystem, sensor is a component, sensor is a device. We can say the sensor is a machine that we can using sensor for to detect the changes in the environment. Okay. What is the work of sensor? What is the feature of sensor? We can say that sensor, we are using sensors to detect the changes within its environment. Okay, so sensor, so there are many types of sensor. We can say that uh, biosensors. Okay, and there are electric sensors. Many types of sensors are there. Okay, so this is the basic definition. Sensors means what? If sensor is a device, we can say that sensor is a subsystem which we are using to detect the changes in the environment. Okay, these components will detect the changes in environment. Okay, the second point is actuators. So what is the basic definition of actuators? So basically actuator is a device which will provide the motion to your system, to your component, to your device. Okay, so actuator is a subsystem, actuator is a device which will provide the motion to your system. Okay, the what is the use of activator? Actuator is used to provide motion to your system. Okay, and I think there are many types of actuator, the like hydraulic actuators, pneumatic actuators, electric actuators. So what are the hydraulic actuators? Hydraulic actuators, it means the actuators uh, which are based, which are working on liquid pressure. Okay, if there is liquid pressure, and that liquid pressure will create a motion. Okay, and actuators will run on that liquid motion. Okay, liquid pressure. Okay, so the second type is pneumatic actuator. Pneumatic actuators means what? The pneumatic actuators using the air pressure to give the motion. Okay, so what is third one is electric actuators. What is electrical actuators? Electrical actuators using current to give the motion to any system. Okay, so there are many types of, I think you will get that point, what is actuators. The third point is electronics. Okay, see, the first sensor, actuators. Okay, if you want this, if you want to use the two devices, okay, then these two devices are always merged with the electronics. Okay, if you want to use sensor, then you must have the electronic system. Okay, if you don't have electronic system, then you don't use then you are not able to use that sensors and actuators. Okay, you must merge with that sensors and actuators whenever you are joining these two devices. Okay, you must join with electronics. Okay, so the electronics is, we can say that electronics is a system. Okay, so the main and basic kit, that is Raspberry Pi, and it is a very important kit in the Internet of Thing technology. Okay, in today's session, we are going to learn what is the Raspberry Pi and how we can use the Raspberry Pi to connect multiple devices. Okay, so this is our today's main topic. Okay, so what is Raspberry Pi? I want to tell you some information about that Raspberry Pi. Okay, so what is Raspberry Pi? See, Raspberry Pi is, I think, we can say that it is a kit. It is a electronic circuit. Okay, which is having some GPIO pins, which is having some ports, okay, within it. So I will explain you one by one. Okay, I will give you brief information about the Raspberry Pi. Okay, see, I think you are able to see the picture, okay, which is on our screen. See, the first is this port. Okay, we're starting from this port. This port is for VGA cable. Okay, if you want to connect the Raspberry Pi to your personal computer, then you can directly connect through the VGA cable. So this is the port for VGA cable. Okay, so these two ports are for USB ports. Okay, these two ports are for USB. Okay, you can plug your USB. Okay, you can plug your dongle to that port. Okay, so this is USB port. Okay, this chamber having, I think, two ports, and this is having two ports. So there are four USB ports in the Raspberry Pi. Okay, so this port is for HDMI cable. Okay, see that this port is for HDMI cable. This port is for VGA cable, and these two ports are for USB. Okay, so and this is a small port. See, this is a small port. This small port is for your power adapter. Okay, so after that, this port is for your camera setup. Okay, after that, this is your Broadcom chipset. After that, these are 40 GPIO pins, that is general purpose input output pins. Okay, I will show you the picture, okay, which is related to that GPIO pin. Okay, or GPIO, we can say that GPIO configuration. Okay, so if you want to connect devices, okay, you must have to use that GPIO pins, okay, to connect that multiple devices, okay, to the Raspberry Pi. Okay, so this there are 40 GPIO pins. GPIO pins for general purpose input output pins. Okay, so this is GPIO pins. There are 40 GPIO pins. So GPIO pin contains some 5-volt power supply pin, or some ground pin, or we can say that 3-volt power supply pin, or some general purpose input output pins. Okay, so this is all about the Raspberry Pi. Okay, and there is one more port, okay, which is on the back side of the Raspberry Pi. That is this port is for micro SD card. Okay, you have to uh, store the files which are related to that operating system, okay, into that SD card. And if you put that SD card into that Raspberry Pi, okay, and when you connect that Raspberry Pi to your personal computer, it will automatically take, and it will automatically run your operating system, okay, to your personal computer. Okay, so this is all about the Raspberry Pi. I will tell you again. So what is this? Is the VGA cable port. These two are for USB port. Okay, this is HDMI port. This is also for camera port. This is the power adapter port. This is camera port. This is BCM chipset, Broadcom chipset. Okay, this is these are uh, GPIO pins, 40 GPIO pins. Okay, and this is micro SD card slot. Okay, so see, there are many types of Raspberry Pi circuits. Okay, like Raspberry Pi 2, Raspberry Pi 3, 3B plus. Okay, we are using for this session. We are using Raspberry Pi 3B plus. Okay, Raspberry Pi 3B plus. Okay, so in today's session, we are going to learn that two practicals which are related to the Internet of Things technology. Okay. See, this is a very mm, basic course for IoT. Okay, so I don't want to go for advanced. Okay, so these are very basic practicals for that IoT technology. The first is LED blinking by using Raspberry Pi, and second one is that displaying time over the 4 by 7 segment display. Okay, by using same that Raspberry Pi kit. Okay, so we will see the first uh, practical, that is LED blinking by using Raspberry Pi. Okay, so I think in that practical we are using one LED pin. Okay, so this first picture is of LED pin. Okay, see, LED pins having the two nodes. Okay, the first node, that is the longer node, and second node, that is the shorter node. Okay, so this longer node, you can say that the longer node is positive node and the shorter node is negative node. Okay, so this is LED. So in second picture, I think you are able to see that in second picture there is a register. Okay, where in this practical we are using register. Okay, so what is the use of register? See, if you are using register into your circuit, then it will automatically control the flow of current. Okay, so what is the work of register? Register will control the flow. Register will control the fluctuations of current. Okay, so when you are dealing with the Raspberry Pi and the GPU ports, you must have to use that register. Okay, while connecting LED. Okay, the third one is the jumper wire. Okay, jumper wire, see, if you want to connect two devices, then you must have to use that jumper wires. Okay, jumper wire are having many types of jumper wire are there. I think the first one is female end, and the another end is that male end. Okay, sometimes there is female to female jumper wire are there, female to male jumper wire are there, male to male jumper wire there. So in this practical we are using male to female jumper wire. Okay, so what is the requirement for this practical? Okay, the first requirement is LED. The second requirement is register. You have to use 20 ohm register or 30 ohm register, no problem. Okay, the third requirement is jumper wire. Okay, so I will show you. I already connect that Raspberry Pi to my PC. Okay, so I will show you how you can start your Raspberry Pi. Okay, set up to your PC. So first you have to go to the advanced IP scanner, scan the IP address. Okay, you just have to use the portable version. Okay, so I already connect that. Okay, you just have to go through this app. It will automatically show you what is the IP address of your Raspberry Pi. Okay, I think you're able to see. You just have to scan that system. Okay, so it will automatically detect what are the IP address, what is the IP address for your Raspberry Pi. See, this is the IP address 192.168 or 137.1 160. This is the IP address. You have to copy this IP address. Okay. After that, you have to go through the VNC viewer. You have to paste their IP address and enter. Okay. So the username is Pi and password is Raspberry. So this is our, when you install the Raspberry Pi operating system into your PC. So this is your desktop. Okay. So see, for for the practical purpose, okay, in IoT technology, for the practical purpose, we are using a Thony Python idle. Okay. So this is our software. Okay, we are using Thony Python idle to run the software. Okay, to run the various code which are related to that. Okay. uh, which are related to that LED blinking practical. Okay, so I will explain you first what is the code for LED blinking. Okay, see, this is a shell. Okay, in this shell, you will see the output. Okay, so this is the code for LED blinking. Okay, and we are using Python language for uh, to uh, give the various command to our hardware system. Okay, so in this system we are using just Python language. Okay, so the first is import time. Okay, so why you are using import? Okay, so why we are using import? Okay, see, if you want to import, if you want to download some declarations, okay, from the library, then you must use import. Okay, so this is import, and this is a, see, import time, it means what, you are taking some uh, declarations from the library. Okay, if you want to download some functions from the library, then you have to use that import command. Okay, so first import time, it means you are importing time from the library. Okay, import raspberry pi dot gpio at gpio, so you are importing that gpio pin numbering system from the raspberry pi hardware system. Okay, so the third point, that is gpio set mode. So what is the actual, what that set mode tells us? Okay, that it tells us the library which pin numbering system you are going to use. Okay, so what is set mode tells us? Okay, see, in GPIO pin numbering system, there are two types. See, if you are using that GPIO system, okay, GPIO pin numbering. So there are two types of pin numbering. Okay, you can use in your program. Okay, the first one is board numbering, that is physical pin numbering system, and the second one is that Broadcom chip, Broadcom uh, channel, Broadcom SoC channel chipset, we can say that numbering system. Okay, so we are using BCM. It means what, Broadcom SoC channel numbering system. Okay, you can, if if you are very good in programming, then you can use that BCM numbering system. If you're not good with that programming, then you also use for, you can go for the board pin numbering system, that is physical pin numbering system. Okay, so to choose correct pin numbering system, you use the command that is set mode. Okay, so what is setup? Okay, if you select the, what is the numbering system which you are using that in that practical, then you must have to select which pin numbering, which specific value of that pin. Okay, you have to put that initial value of that your pin number. Okay, see, if you are using setup command, then this setup command is useful to specify the initial value of your output channel, that is from from what kind of numbering system, from what numbering system you're going to take output. Okay, and what you have to mention that pin number. Okay, so we are taking, we are, see, we are I think we are using BSIM pin number system. Okay, so from BSIM pin number system we are using pin number 17. Okay, okay, so this is our while loop. We're using again GPI output. We see while loop is for what? This is universal truth. Okay, so if you run this code, okay, this will automatically see LED on off, LED on off. Okay, so this is a code for LED blinking. Okay, so I will show you one video, okay, from my channel, so you will get a better idea. Okay, uh, for your that practical. Okay, so you just go to the YouTube, you just search my name, that is Umkar Kapdi. Okay, you will get my channel is the first. Okay, okay, so this is for practical what is LED blinking by using Raspberry Pi, how you can make circuit. Okay, so I will show you how you can. Welcome all. I think this is our practical number first, LED blinking by using Raspberry Pi kit. Okay, so in this practical we require two jumper wires. Okay, these are two jumper wires. Okay, there is the jumper wire having one end is female side and the another end is male side. Okay, so after that we require one register. Okay, because we are dealing with the Raspberry Pi and the breadboard. Okay, and most important, it is must that you have to use that register when you are dealing with LEDs. Okay, and after that you want one LED. Okay, this is your LED. Okay, see this LED having the longer side. Okay, see that, I think you are able to see this LED having longer side. Okay, and one is shorter side. The longer side is that positive lead and the shorter side is negative lead. Okay, this is our Raspberry Pi kit, and you want one PC which is having that Raspbian OS. Okay, I will show you how we can connect the, how we can make connections, how we can make circuit. Okay, so I will show you how we can make the circuit. The first thing, we are taking output from the pin number 11. Okay, and we are using I think we are using board pin number system. Okay, you can either use BSIM pin number system or board pin number 16. Okay, I think I am telling you about the physical pin number system. Okay, that is pin number 11. Okay, so I'm taking input from pin number 11. 1 2, see, this is 1 2 3 4 5 6 7 8 9 10 and 11. Okay, this is pin number 11. Okay, I'm joining this pin here, so we are taking input. After that we have to join our LED. We are joining longer side, it means positive side of LED to the output terminal. Okay, so we join positive side of LED to the output terminal. Okay, after that you have to join register. Okay, so we are joining register to the negative side of the LED. Okay, we joined it. Okay, after that we have to complete the circuit, so we can make ground. Okay, so 1 2 3 4 5 6, pin number 6 is ground. Okay, and we can complete the network, we can complete our circuit. Okay, I think you are able to see how we make circuit. Okay, see, I will tell you again. The current will first come into this yellow wire. After that it will come here. It will first touch with the it will first touch with the positive side of LED. After that it will passing through the LED. Then it will be in the negative side of LED. After that it will pass through the resistor, and after after that the circuit will be completed. Okay, so I will show you how this code is in. Okay, so I already make a code here. Okay, okay, you just have to run that code. See, when you run the code, your LED get blinked. Okay, and you will get your output into the shell. Okay, see, okay, hope you will get the exact idea how we can connect the LED by using Raspberry Pi. Thank you so much. Okay, so this is our first practical. Hope you will get that basic idea. Okay, so how we can connect that LED, okay, to your breadboard, and by using this all kind of software, that is Thony Python. Okay, so we will go for our second practical, that is 4-bit 7 time, displaying time on 4-bit 7 segment display. Okay, so see, you directly go for the video. Okay, will show you the video, okay, which is related to the 4-bit 7 segment display. See, this is my channel. Okay, and this is the video. Okay, enjoy that video. Hello everyone, this is our second practical. It is 4-bit 7 segment display. It is time displaying over the 4-bit 7 segment display by using the Raspberry Pi circuit. Okay, so first I want to tell you what is the what is the actually 4-bit 7 segment display. Okay, so see, I think you're able to see the picture of that 4-bit 7 segment display. Okay, so first image is the front side of that 4-bit 7 segment display, and this is the back side of 7 segment display. Okay, so the 7 segment display having the 4 output pins. Okay, so the first output pin is for ground. The second output pin, see, you can, I think this is a very small. See, the first output pin is for ground, the second one is for VCC, third is DIO, and fourth one, that is clock. Okay, first pin that is ground, second pin is to give a 5 volt power supply, that is VCC. The third is that is direct input output pin. Okay, or we can say that data input output pin, or the fourth that is clock pin. Okay, for to display the time, okay, to get the output. Okay, so this is our front side. So why we can say that 4 bit and 7 segment display. Okay, see the display having the 4 bit, 1, 2, 3, and 4. Okay, and each bit is distributed in a 7 segment. So that's why we can call this display as a 4 bit 7 segment display. Okay, so this is the basic information about the 4 bit 7 segment display. Okay, so we'll watch that video and get the basic idea of that 4 bit 7 segment display. Okay, it is 4 bit 7 segment display. It is time displaying over the 4 bit 7 segment display by using the Raspberry Pi circuit. Okay, so this is our 4 bit 7 segment display. So why we can call it 4 bit 7 segment? Because there are 4 bits, bit number first, second, third, and fourth. So 4 bit, and each bit having 7 segments. So that's why we're calling this 4 bit 7 segment display. Okay, after that, this 4 bit 7 segment having the TM1637 chipset. Okay, which are having that TM1637 chipset having the 4 output pins. Okay, that is first one is clock, second one is DIO. First one is clock, second one is DIO. That's for data input output. Third one is VCC. VCC means for power output. Okay, and fourth one is ground. Okay, so we make connection. Okay, so the first wire is orange wire. So the orange wire is for clock pin. Okay, so we are connecting this clock pin. So we are connecting this clock pin to the pin number 16. Okay, we are connecting this clock pin to pin number 16. Okay, after that DIO, we are connecting this yellow pin to the pin number 18, that is data input output pin. After that third pin, that is 5 volt power supply. Okay, so VCC pin, we are going to connect VCC pin to the pin number 14. On all this pin numbering is that physical pin numbering, that is port pin numbering. Okay, after that fourth one is that ground. It means we are going to connect ground pin to the pin number 14. Okay, so this is all about the connection. Okay, so I will show you how we can run the actual code to get desired output. We can see there are 4 output pins. Okay, so the first ground pin. Okay, we are connecting that output pin to the GPIO pin setup. Okay, so the first ground pin of the 4 bit 7 segment display. Okay, we are connecting that first ground pin of that 4 bit to the pin number 14. Okay, and this we are using that physical pin numbering system for the GPIO setup. Okay, so for GPIO pin number 14. Okay, and for the for the 4 bit 7 segment display, the ground pin. Okay, so the ground pin is connected to the pin number 14 of GPIO system or GPIO setup. Okay, so the second, that is VCC. VCC pin is from that 4 bit 7 segment display. Okay, and that VCC pin, we are going to connect that VCC pin to the pin number 4 of that GPIO pin setup. Okay, after that DIO pin is connect to the pin number 18 of GPIO pin number system, and the clock pin is connect to the pin number 16 of GPIO pin setup. Okay, run the actual code to get desired output. Okay, first step is that you have to make folder into that home PI. Okay, and that folder is 4-digit time. Okay, after that open terminal. Okay, and type cd 4 digit time slash. Okay, after that type plus, after that clear. So see okay, clear. So to that type w get https double semicolon and website ISP raspberry tips dot nl slash files slash tm1637.py. Okay, so we write this command because we want to download the files which are related to tm1637. Okay, so tm1637 is a chipset which are located in the 4-digit 7 display. Okay, so see the HTTP request sent by default request. Okay, so I think these files are saved. Okay, after that we have to type ls. Okay, see we will got our file. Okay, that is tm1637. Also we have to check this file. Okay, in 4 digits see we will get this file. Okay, after that we have to clear. Okay, and you have to move your coding file into that 4-digit time. Okay, so I have to paste. This is coding for 4-digit 7 segment display, and this is the file where this is a file for the tm1637. Okay, so you have to, after that you have to just run your that coding file python, and my coding file is clock.py. Okay, see when you run this file you will get your output. Okay, into your display. Okay, so this is all about the 4-digit 7 segment display, and I want to show you the code for that. Okay, so the code is here. You will get the code file from the internet. Okay, the code file, in that code file there is import system, import time, import date time. See, these are all importing files. Okay, from the library. So see that we are using command that is import. Okay, the first we are importing system, second we are importing time, third we are importing date time, fourth we are importing Raspberry Pi system, that is GPIO pin setup. After that we are importing a TM1637 chipset, which are which is located in that I think in that 4-bit 7 segment display. Okay, so we are importing multiple files from the directory. Okay, this is the important file. Okay, I think you will understand the concept that is practical. Okay, that is 4-digit 7 segment display. Okay, thank you so much. Okay, I think uh, you will get you will get that all idea which is related to the Internet of Things. Okay, I think uh, we first we first conduct that practical, that is LED blinking by using Raspberry Pi, and second one is time displaying on the 4 by 7 second display. Okay, so this is very easy practicals. Okay, and these practicals are very easy to understand. Okay, so hope uh, you got that idea. Okay, which is behind that devices which we are connecting in the IoT technology. Okay, so thank you so much, and we are ending this today's session here. Okay, so thanks a lot.